The lesson topic for this video is compound probability using OR. Alright, so compound events, you guys, are two or more events. Okay? So in the two events, we've got two things that can happen. Events are either overlapping or they are disjoint, which is another way of saying mutually exclusive. Okay? Exclusive of each other. An example of overlapping events is if I said I was going to randomly choose a person in this class, and I want to know if they are a sophomore or if they have brown eyes. You can see that they overlap because if I put S here in this circle for sophomore, and I put a B here for brown eyes, there are people who land in the overlapping section that are both sophomores and have brown eyes. Whereas the example on the right says, what if I was going to randomly select a person in this class and they are a sophomore or they're a junior? Well, sophomores might go here again, and juniors go in this bubble, and in no way is there a person that is both a sophomore and a junior. So the most important thing that you need to do when you see the word OR in these types of problems is ask yourself, are the events overlapping or are they mutually exclusive or disjoint? Okay, so the way we compute probability of disjoint events is going to be that we just simply take, as we've seen in previous examples with the word OR, we're going to take the probability of the one thing and we're going to add it to the probability of the other thing, and then we just get our total. Okay, so that one is pretty normal. The overlapping events is the one that is going to be something you need to be careful about. So the probability of A or B happening when you know the events overlap, so sophomores and brown eyes, is that you have to add the probability of the first thing, so let's say sophomore, plus the probability of the second thing, so let's say brown eyes, but then we need to subtract any overlap that occurs. So any that you counted both in this category and in this category, you need to subtract because you counted those students twice. So we'll try this example here. There are 20 students in AP Statistics. There are 120 students in Pre-Calc. 6 students take both. Find the probability that a randomly chosen student at Osseo Senior High, which we have now 2,000 students, takes AP Stats or Pre-Calc. Okay, so what we have to find here is we have to find the probability of stats or Pre-Calc. I'll just abbreviate that. So the probability of a student taking stats or Pre-Calc, we know we have to find the probability of a student taking stats and add it to the probability of a student taking Pre-Calc, but then what we have to remember is that this is an overlap situation. These events are not mutually exclusive because we have 6 students who take both. What that means is we're going to find the probability of statistics plus the probability of Pre-Calc, and then we're going to subtract the overlap. So the probability of a student being in stats is 20 out of 2,000, plus the probability of a student being in Pre-Calc is 120 out of 2,000. And then we have to subtract the students we counted twice. And we counted 6 students twice because it says it right here. Sometimes it's not quite that clear in the directions. So 6 out of 2,000 students was counted twice, and so we have to subtract them. So 20 plus, and remember, when our denominators are the same, we can just add the fractions as they are. So 20 plus 120 is 140, and 140 minus 6 is 134. So our final answer is 134 out of 2,000. Okay, in this example you have 8 red cards numbered 1 through 8 and 5 blue cards numbered 1 through 5. you're going to select one card. So find the probability of selecting, part A, a red card or an even card. If you think for a minute about red or even, we're talking about either overlapping events or mutually exclusive or disjoint events. The question you have to ask yourself is, can I draw a red card that is also even? And the answer is yes. The 2 and the 4, the 6 and the 8 are all both red cards and even. So because they are overlapping, we need to make sure to subtract those overlapping results. So the probability of getting a red card, there are 8 red cards out of how many total cards? 13. Plus the probability of getting an even card. So even cards are 1, 2, 3, 4, 5, 6. So there are 6 even cards we could draw out of 13. And then we need to subtract the overlapping cards, the cards that we counted in both. And that would be 2, 4, 6, and 8. The even red cards. There's 4 out of the 13. So when we do our math here, we're going to end up with 10 out of 13. Okay, so the second example. What's the probability that the card you draw is a red 2 or a multiple of 3? Now the first question again to ask yourselves is this overlapping or disjoint? Well, a red 2, here it is, red 2. There's only one red 2. Okay? Is that red 2 a multiple of 3? 3, 6, 9, 12. No, it's not. So, the probability of getting a red 2 and a multiple of 3 are not overlapping events. So we can just add their probabilities. So a red 2, there's only one red 2 out of the 13 cards, plus multiples of 3. 3 is a multiple of 3, so that's 1. 3 is a multiple of 3, that's 2. 6 is a multiple of 3, so that's 3. There are 3 cards out of 13 that are multiples of 3. If we add these up, because there's no overlapping cards, we will get 4 out of 13. Okay, let's try the next one. A blue card or an odd card. So think for a minute, are these overlapping or are they disjoint? Well, can you draw a blue card that is also odd? Yes, you can. So you need to be careful to pay attention to the overlap. So how many blue cards? Well, 5 chances out of 13 cards plus odd cards. Well, 1, 2, 3, 4, 5, 6, 7 cards are odd. So 7 out of 13. And then we need to subtract the overlapping cards, the cards that are both blue and odd. So that was 1, 2, 3. 3 cards that we need to take away because we counted them twice. All right, so we have 5 plus 7 minus 3, so that's 9 out of 13. So that is our probability. The last one. A multiple of 3 or an odd card. Well, multiples of 3 does overlap with odd cards, so we have to remember to subtract the overlap. Multiples of 3, 1, 2, 3 out of 13 cards, plus odd cards, 1, 2, 3, 4, 5, 6, 7, and then subtract the cards that overlapped. Okay, so the multiples of 3 that are also odd, that's this one, multiple of 3, odd, multiple of 3, and odd, and this is a multiple of 3, but it's not odd, so we need to subtract 2 out of 13. So we get 8 out of 13 is our probability. All right, one last set of examples. This says, in a survey of 125 people, 62 said they like coffee, 43 said they like tea, and 21 said they like both. Is this disjoint or overlapping? Well, this is overlapping because of these 21 people that like both. So how many of them like both coffee and tea? Well, 21. So what is the probability that a randomly selected person will like coffee or tea? Well, we have 62 people out of 125 that like coffee. Plus, we have 43 people out of 125 that say they like tea. But we need to subtract the people who said they like coffee and tea, which was 21 people. So that will be 84 out of 125. So again, if we randomly selected a person from this survey, there is 84 over 125, or 67.2% likelihood that they will like coffee or tea. What is the probability that a randomly selected person will like coffee and tea? Well, again, that means that they like both, which is simply 21 out of 125.